This is your Exam 5 review for Module 5, and we'll be starting with complex numbers. So looking at the top, number 1 says write the expression as a product of a real number and I. Well, if you remember, when you have a negative under an even root, you have to pull out the I, or the complex piece. So what we're going to do is pull out the I, and then we're going to break down square root of 200 into 100 times 2. Now I can take the square root of 100, which is 10. The correct way to write this is 10 radical 2, and then the I comes last. 10 radical 2, I. The I always comes again last. Here it says to perform the indicated operations, and we are to give our answers in the form of A plus BI. A being the real number part, BI is the imaginary part. So we're just going to be adding or subtracting like terms. So I've got a negative 2 and a negative 8. That makes a negative 10. A positive 5i and a negative 7i is minus 2i, and you cannot combine those because they're not like terms. Here I have subtraction, so we're going to follow the same rule we do with polynomials. Change to addition, change the signs that follow, and then you are going to combine like terms. So now I have a 5 plus a 9, which is 14, and then I have a 4i plus 3i is 7i. So 14 plus 7i. Next, and this is where we have to begin to be very careful, we have multiplication of imaginary numbers. So you can't just multiply these using the product rule and say a negative times a negative is a positive. You have to pull the i's out. So we have I radical 5 times I radical 7. Now we're going to multiply the like parts. I times I is I squared. Radical 5 times radical 7 is radical 35. But we know that when we're talking about complex numbers, I squared always has to be replaced with negative 1. You don't leave an I squared. So that gives us negative 1 radical 35, or if you prefer, just negative radical 35. The same thing applies here. We can't just cross cancel those negative signs. You have to pull the I out, the top and the bottom. Then I have radical 72 over radical 8. I over I, however, does make a 1 because it's like something over itself. I'm going to change this to one giant square root. The reason I did that is because 72 is divisible by 8, and I end up with square root of 9, which is just 3, and the i's crossed each other out, making a 1. Here this looks like FOIL, and it is FOIL. So we have 2 minus 2i plus 3i minus 3i squared. But remember, I squared is negative 1. So what I really have is 3 times negative 1. So I've got 2, let's combine these like terms, plus I, and then negative 3 times negative 1 is positive 3, which gives us 5 plus I. So there's a little bit more putting together here than when you are multiplying binomials. Here we want to do the same thing we always do when we see an expression squared. We want to write it twice. So 6 minus 2i, 6 minus 2i, and now you want to FOIL. So that gives you 36 minus 12i minus 12i, and then your last is plus 4i squared, remembering that I squared is negative 1, so it's 36 minus 24i, I combined like terms, plus 4 times negative 1, or 36 minus 4 is 32 minus 24i. Here we're going to clear the denominator of i's by multiplying by the conjugate, just like we did with radicals, and that would be 2 minus I, 2 minus I, and then you've got to FOIL the top and the bottom. So the top would be 6 minus 3I minus 2I plus I squared, which is 6 minus 5I, and then we have plus I squared minus 1. So we'll combine that and simplify in a second. Here I have 4 minus 2I plus 2I. That's the whole reason we use the conjugate. And then minus I squared, which is 4 minus negative 1, which is 4 plus 1, or 5. So continuing a little bit further, 6 minus 1 is 5 minus 5I over 5. And now I can take that further because there is something that goes into each of those 3 pieces. I'm going to divide each by 5, and that gives me 1 minus I over 1, or just 1 minus I. Be very careful with the details on this section on complex numbers, because those I's can become a problem. All right, let's look at the last chapter that we're testing in Module 5, which has to do with quadratics and solving quadratics. So the first one, number 1, says use the square root property to solve the equation. Well, the square root property says to first isolate what was squared. So we're going to move that 36 to the other side. That would be x squared equals 36. And then you take the square root of both sides. The square root of x squared is x. The square root of 36, and this is the part you've got to remember, is plus or minus 6. So if you want to write your answer in set notation, it would be -6 comma +6. Don't forget, when you're taking the square root, we want both the positive and the negative roots. Your quadratic equation should have 2 solutions, and that's how you get the 2. All right, we're going to continue with the square root property. Again, what we want to do is to take the square root of what's been squared. Once it's isolated here. So I do this. Square root of x plus 7 squared is just x plus 7 equals plus or minus. Now we want to break down that 44 into 4 times 11 because it is a perfect square factor. Square root of 4 is 2. Be careful where you write it. It goes right in front of the radical. So I have x plus 7 equals plus or minus 2 radical 11. And now to solve for x, I have to subtract a 7. And this is where you have to be careful how you write this. The 7 can't combine with 2 radical 11. Those aren't like terms. So you get x equals -7. It's just written out front, plus or minus 2 radical 11. I cannot put those together and call it -5 radical 11. They are unlike terms. But I still have 2 answers because I have -7 plus 2 radical 11 and -7 minus 2 radical 11. All right, let's do the same thing here. It's isolated already, so we will take the square root of both sides. So 5x minus 4 equals plus or minus. Let's break that down. 9 times 3. 3 comes out. 5x minus 4 equals plus or minus 3 radical 3. We'll add a 4 to both sides. So far, it's just like the last one. 4 plus or minus 3 radical 3. But there's one extra step here. I have to divide both sides by 5. And so we get x equals 4 plus or minus 3 radical 3 all over 5. That last step really doesn't make it any harder. It's just a division step. Okay, on the next 2, we're asked to solve by completing the square. Now, when you complete the square, you want isolated just the variable pieces with the number on the other side. So we're going to subtract this 63. That gives us z squared plus 18z, and this is where you write plus some magic number equals -63 plus the same magic number. Now, to find that magic number, what we're going to do is take the coefficient of the middle term, so positive 18, divide it by 2, write what you get, including the sign, and circle it, and then you'll know how you're going to write your next step. Take that circled number, square it, and you will get what you were supposed to add, and it will always be positive because we're squaring something. Now, the reason you circle this is because now we have to write this as a perfect square binomial, and what it is z, and then what you have in the circle, plus 9 squared equals negative 63 plus 81 is 18. And now we're back to square root property. Square root, z plus 9 equals plus or minus. Let's break this down. Square root of 9 is 3. Move it up here. A little more space. So z plus 9 equals plus or minus 3 radical 2. Subtract your 9, and we have z equals negative 9 plus or minus 3 radical 2, and you have your two solutions. Notice that when I take the square root, when I use the square root property, I don't have to check them. The only time you're required to check is when you square to solve, not when you take the square root. So here, same thing, complete the square. Let's get that number on the other side before we start. So x squared minus 2x plus some magic number equals 24 plus the same magic number. To find that number, take the middle coefficient, divide it by 2, circle it, square that, and add that to both sides. So this becomes what's in the circle, x minus 1 squared equals 25. Take the square root of both sides. X minus 1 equals, now be careful here. Remember, you want two answers, so it has to be plus or minus 5. And this is where we split it. X minus 1 equals positive 5. X minus 1 equals negative 5. So you're splitting this plus or minus. And then you are solving to get your two answers. So x equals 6. There's one answer. Or x equals negative 4. And once again, we have two answers because we split what came out of our square root sign there. Okay, that is completing the square. So let's look at the quadratic formula, which is another way that you can solve quadratic equations. In the quadratic formula, when you use the quadratic formula, just like with factoring, you have to get it equal to 0 first. So here, I am going to add a 10n to both sides. So 2n squared plus, oops, I forgot my n there, plus 10n equals negative 2. And then I'm going to add a 2 to both sides. And I have 2n squared plus 10n plus 2 equals 0. So I have gotten it equal to 0. Now because those are all even numbers, now how did I forget that n again? I keep doing that. There's an n there. Sorry about that. I could go through and divide everything by 2. It would make the numbers smaller. Or I can identify my A, B, and C just as it is. I'm going to go ahead and divide by 2 because if I can make numbers smaller, I prefer. So I'm dividing this side by 2 and this side by 2. That gives me n squared plus 5n, I'm writing my n this time, plus 1 equals 0. Now I want to identify my A, my B, and my C. A is the coefficient on the n squared, so it's 1. B is the coefficient on the n, so it's positive 5. And C is the coefficient of, it's just the last number left. Now, if you did not divide by 2, this would have been 2, 10, and 2. And believe it or not, it's going to come out exactly the same either way. So our formula says n equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's your quadratic formula that you have to have memorized. So n equals negative 5 plus or minus 5 squared is 25 minus 4ac all over 2a, or n equals negative 5 plus or minus the square root of 25 minus 4 is 21 all over 2. And there you have your answer. Nothing will cross cancel. All right, let's do the same thing with number 7. We want to get it equal to 0. So we have 8x squared plus 7x plus 2 equals 0. This time I can't make the number smaller, so I'm going to identify the a, b, and c. A is 8, b is 7, c is 2. So we have x equals the opposite of b plus or minus b squared minus 4ac all over 2a. Or x equals negative 7 plus or minus, this is going to be 49 minus 64, I believe. 4 times 8 is 32 times 2 is 64. Yep. All over 16. Or negative 7 plus or minus square root of negative 15 all over 16. Now, you may think you're finished, but you can't leave that negative under there. There's an I that has to come out. So what you end up with is x equals negative 7 plus or minus square root of 15i all over 16. That is an acceptable answer, or you can write it like this. X equals, I'm going to make two fractions here, negative 7/16 plus or minus square root of 15 over 16i. Just got to keep that plus or minus in there. I'm fine with you leaving it like this. All right, number 8, we're going to solve equations that are quadratic in form, meaning they don't look quadratic until you start working with them. This one is a review of another module that we did on rational equations. So in order to clear those denominators and solve for x, I have to multiply by the LCD. Now, the other thing you want to remember is, because I have variables in the denominator, there are some things that x can't be, and maybe we should identify those first. So I have an x minus 1 here, so I know that x can't be 1 because that would make a 0. And here I have x in the denominator, so I know that x can't be 0. So you want to keep those two things in mind. So what we have is 4 over x minus 1 plus 9 over 1 equals negative 7 over x. And to clear the denominator, get a different color here, we need to multiply by the LCD. Well, the LCD is in this case is whatever it would take to cross cancel all denominators. So I would need an x and an x minus 1. So you're going to put each term in parentheses, and beside it you are going to write x times x minus 1, x times x minus 1, x times x minus 1. And the reason you do that is because it will cause those denominators to cross cancel. So those cross cancel, and I'm left with 4x plus, nothing cross cancels here, so I have a 9x times an x minus 1, we'll distribute shortly, equals negative 7 times x minus 1. Let's go ahead and distribute. That is going to give us 4x plus 9x squared minus 9x equals negative 7x, negative times negative, plus 7. Combining like terms, I have 9x squared minus 5x equals negative 7x plus 7. This is quadratic, so I need to get everything on one side equal to 0. So I'm going to add a 7x 9x squared plus 2x equals 7, and subtract, that's a 7. A 7, so 9x squared plus 2x minus 7 equals 0. Now, from there, what we want to do is we want to pick one of our methods for solving quadratics. Factoring, square root property, complete the square, or quadratic formula. Well, I always try factoring first. This is a terrible example to use for completing the square because it doesn't have a 1 in the front. It's not set up correctly for square root property, so you only have factoring or quadratic formula here. So I'm going to try my long process. I'm looking for factors of negative 63 that combine to make positive 2. Well, I know what those are, 9 and 7. So I am going to break down this into these two pieces, plus 9x minus 7x, bring down my last, minus 7 equals 0. I have 4, so I'm going to group because of the negative right here. I'm going to make that correction on the last term, and now I'm going to factor out the GCF. So 9x times x plus 1, bring down your minus, 7 times x plus 1 equals 0. X plus 1 times 9x minus 7 equals 0. And now we set each of those factors equal to 0. So x plus 1 equals 0, or 9x minus 7 equals 0. Subtract a 1 here. Check it against your domain restriction. Yep, negative 1 is okay, so there's one answer. Add a 7 and divide by 9. That's okay, so x equals 7/9. And I have my two solutions. All right, on the next page, we have another one that is quadratic in form. So I want to get, I could get everything equal to 0, but as soon as I see that radical sign, that tells me I want to isolate that term and then square both sides. So I'm actually going to subtract a 1. So 2x minus 1 equals square root of x. Now I'm going to square both sides to get rid of that radical. So I square. Remember, this is a FOIL. Write it twice and FOIL it. When you do, you're going to get 4x squared minus 4x plus 1 equals x. Now what we want to do is to, since I see the squared term, I know it's quadratic, I want to get everything on one side equal to 0. So I'm going to subtract an x. I have 4x squared minus 5x plus 1 equals 0. Again, I'm going to see if it's factorable before I use that quadratic formula. So 4 times positive 1 is positive 5. I want factors that add up to negative, 4 times 1, excuse me, is positive 4. That was silly. And I want factors that add up to negative 5. That's going to be a negative 4 times a negative 1. So I can factor. So I'm going to bring down, let's do this up here. I'm going to bring down the first. I'm going to break down this one into these two pieces. So minus 4x minus 1x. Bring down the last. Group, since I have 4. Once again, I have a minus in between. So I'm going to make that correction on my last term. And I'm going to factor out the GCF. So 4x times x minus 1 minus 1 times x minus 1 equals 0. My first factor is x minus 1. My second factor is 4x minus 1 equals 0. X minus 1 equals 0, or 4x minus 1 equals 0. X equals 1, and there's no variable in a denominator, so we're okay there. Or add a 1 and divide by 4. X equals 1/4. And you're thinking, oh yay, I'm finished. But think about how we solved this. We squared. So you are required to check both of those solutions. So let's first check 1. Get this where you can see it. In the original, we're checking this answer first. So that would be 2 times 1 is equal to square root of 1 plus 1. Or 2 is equal to 1 plus 1. Well, that one does check. So yes, that one is a solution. Now we're going to check 1/4. Just because 1 worked doesn't mean 1/4 is going to work. Maybe it will, maybe it won't. So 2 times 1/4, is that equal to square root of 1/4 plus 1? Is 2/4, or 1/2, equal to square root of 1/4 is 1/2, because 1/2 times 1/2 is 1/4 plus 1. Well, is 1/2 equal to 1/2 plus 1? Absolutely not. So we have to discard this answer. That answer didn't work. And so we really, even though we got 2, only one of them is our solution. It's the only one that worked. All right, let's look at another type of equation that is quadratic in form. And it's an equation that we solve with what's called substitution. So as you can see, it's a kind of a complicated looking equation. So we're going to say, let whatever this middle piece is, let 4m minus 4 equal u. That would give us then u squared plus 4u plus 3 equals 0. So I'm taking out the 4m minus 4 and putting in a u. This is a short process trinomial, so I need factors of positive 3 that add up to positive 4. That's 1 and 3. So u plus 1 times u plus 3 equals 0. Set them each equal to 0 and solve. We get u equals -1 or u equals -3. But remember, we were not looking for u to begin with. We were looking for m. And u is just a stand-in for 4m minus 4. So I'm going to take, if u equals -1, then 4m minus 4 equals -1. And if u equals -3, then 4m minus 4 equals -3. And now I have to solve those two equations where I have substituted back. First I substituted 4m minus 4 for u, and now I'm putting the 4m minus 4 back into what we got for u. So when I solve this, 4m equals 3, and I divide by 4, and I get one solution is 3/4 for m, which is what we were looking for. Here, when I add it back in, I get 4m equals 1, divide by 4, and I get, or m equals 1/4. And I have my two solutions. I didn't square anything, so I'm not forced to check them, but it's just that when you get to the u equals, it makes you think you're finished. But remember to back substitute, go back and substitute in to get the original variable. Looking at some applications, it says Matt Porter is building a new barn with length 10 feet more than width. Okay, if it's a length and width, then it's a rectangle. Length, width, let's fill in what we know. Length is 10 more than width. So it's 10 plus w. While determining the footprint of the barn, he measured the diagonal at 50 feet. And all of a sudden, I know this is a Pythagorean theorem problem because I am talking about a right triangle. What will be the dimensions of the barn? So we know that the formula is a squared plus b squared equals c squared. I know this has to be my c. I'm going to let this be my a and this be my b. It doesn't matter which is which. So a w squared plus b 10 plus w squared equals C, 50 squared. Or W squared plus, FOIL this out, and you're going to get 100 plus 20W plus W squared equals 2500. Combining like terms, 2W squared plus 20W plus 100 equals 2500. Since it's quadratic, we're going to get it equal to 0. So we have 2W squared plus 20W minus 2400 equals 0. Now I notice that I can make my numbers smaller by dividing everything, both sides, by 2. And I'm going to move this over here so you can see it. It's going to give me W squared plus 10W minus 1200 equals 0. It is a short process trinomial. I need factors of 1200 negative that add up to positive 10. Now, you may not know what they are off the top of your head, but if you'll think of this as 12, negative 12, I could have 4 and negative 3, put zeros on those, and I have it. 40 and negative 30. So it's W plus 40 times W minus 30 equals 0. Set each of those equal to 0 and solve just like you always do with zero factor property. Here I'm going to get width as negative. Nah, we can't have negative width, so that's not going to work. But here we are going to get that the width is 30 feet, and to find the length, I'm going back to that. The length is 10 plus the width, so the length is 40 feet. And you have the dimensions of both of them. All right, let's look at a couple more application problems and we will be finished. It says a ball is projected upward from the ground. And so this is one of those problems where you've got this ground, it's projected upward. Its distance in feet from the ground at any t seconds is given by this formula. And of course, then it comes back down. And we want to know at what times, plural, will the ball be 213 feet from the ground. So if this is equal to the height of the ball, what this is really saying is when does the height equal 213? That's what it's asking you. So we're going to take this equation, remember S of t is just an announcement of height, and we're going to set it equal to 213. Now there's a lot that needs to be done to this. I don't want a negative on my squared term, so I'm going to move these two pieces over here. I'm going to add a 16t squared, I better show that, and subtract a 128t on both sides. And what that gives me is 16t squared minus 128t plus 213 equals 0. And unfortunately, I don't think there's anything I can divide by to make those numbers smaller. I am certainly not going to attempt to factor that. It's not factorable anyway, just saying. So I'm going to go ahead and use the quadratic formula and identify my A, B, and C. So A is 16, C is negative 128, B, excuse me, and C is 213. And if you don't have a calculator, you want to pause this and go get one. Now we just fill in using the quadratic formula. So the opposite of B would be the opposite of negative 128. So 128 plus or minus negative 128 squared minus 4AC all over 2A. We can simplify that a little bit before you put it into the calculator. It's going to be 128 plus or minus, if you square this and then multiply this all together, here's what you're going to get. 16384, that's what you get when you square, minus 13632, all over 2 times 16, 32. Let's move it up a little bit. So t is equal to 128 plus or minus the square root of 2752 all over 32. Now here's how I did this at this point. I put it into my calculator twice. T equals 128 plus the square root of this over 32. And then t equals 128 minus the square root of that over 32. And when you do that, when you do t equals 128 plus the square root of that, you get 5.6, I rounded off, seconds. And when you do t equals 128 minus the square root of this over 32, you get 2.4 seconds. So we actually have two answers, and the reason is, let's go back to our drawing, it hits 213 feet going up, but then it hits that same height coming down. So here it's at 2.4 seconds, and here it's at 5.6. So it makes sense that you get two solutions there. All right, number 13. A 13-foot ladder is leaning against a house. All right, on these, I always have to draw a picture, pardon the artwork. So let me use a different color. So here's this ladder, and I know that it is 13 feet. Okay, it's leaning up against the house. The distance from the bottom of the ladder, so right here, to the house is 7 feet less than the distance from the top of the ladder to the ground. So I'm going to let this distance be x, which means this distance is 7 less than that. So that's kind of the key to this, is knowing how to label. Because I don't know what this distance is, I called it x. And once again, you can see we have a Pythagorean theorem problem. So if this is my A and this is my B, this one has to be C. So I have x squared plus x minus 7 squared equals 13 squared, or x squared plus, FOIL this, x squared minus 14x plus 49 equals 169. Subtract a 169 from both sides and combine like terms here. 2x squared minus 14x minus 120 equals 0. This is a good one because I can divide everything by 2. X squared minus 7x minus 60 equals 0. I need factors, let's do this on this side. I need factors, short process factoring, of negative 60 that add up to negative 7. Now you may or may not know them. So if I start going through the list, I would have 60 times 1, 30 times 2, 15 times 4, divide this by 3, multiply by 3, and that's where I can get my 7. I'm doing the factoring quickly because at this point I'm assuming you know how to factor. So that's going to give us x minus 12, x plus 5 equals 0. So x minus 12 equals 0, or x plus 5 equals 0. This one's going to give me a negative measurement, so I can't have that one. But here I get x equals 12, and you're probably so excited that you're finished. But let's look at what the question asks. I just found that x equals 12 feet. It says, how far is the bottom of the ladder from the house? We want to know this distance, so I have to say that distance is x minus 7, or 12 minus 7, which is 5 feet. So that was just about reading carefully. It's true that x is 12, but we wanted to know this distance. All right, the last two problems are literal equations where we are solving for a different variable. So here we want to solve for e. And I'm going to rewrite this equation. N equals AB over E squared. First thing I need to do is get rid of this denominator. So I'm going to multiply both sides by E squared. I get E squared N equals AB. We're trying to isolate the E, so I'm going to divide by N. I get E squared equals AB over N. Now it looks like all we need to do is just take the square root of both sides. E equals square root of AB over square root of N. Problem is you can't leave a radical in the denominator. So we're going to rationalize that denominator like you were taught in another module. And that gives me E equals square root of ABN, those multiply together. Square root of n times square root of n is n. And that's the answer you want. You are not finished at this step until you rationalize. Next one's a little bit different. We want to solve for p, and it's under the square root, so we need to get that radical gone first by squaring. So s squared equals pq over n. Now I need to get rid of the denominator, so I multiply both sides by n. That gives me s squared n equals pq. And since I want to solve for p, all I need to do is divide by q, and I get p is equal to s squared n over q. I think this one was a little bit easier than this one because I didn't have to do any rationalizing of the denominator on this last one.